Bismillahirrahmanirrahim. Assalamualaikum. Today we are going to start class 9, subject physics, and topic of today's lectures are same 4.1, 4.2, 4.3, as we have done these examples 4.5 and 4.4 in our last and MCQs we did last time. For today's lecture, we are going to solve 4.1, 4.2 and 4.3 problems. Pages covered. These problems are on page number 105. Today, you will not see these pages in the pages 98, 99, 104. Only 105 page today. 4.1 problem, 4.1, 4.2 and 4.3 we will do today. Okay. So what we have done. So this is our first problem on page number 105. I read the first numerical on page number 105 of 9th class book. Find the return of the following. Find the return of the following forces: 10 Newton along x-axis, 6 Newton along y-axis, and 4 Newton along negative x-axis. So this is the statement of the numerical. Find the division 4.1 on page number 105. Repeat 4.1 numerical problem 4.1 on page number 105. Find the return of the following forces: 10 Newton along x-axis, 6 Newton along y-axis, 4 Newton along negative x-axis. So I start the solution. Step 1, in this numerical, step 1, we need to choose a scale. So we choose a scale, 1 Newton equals to 1 centimeter. Then our 10 Newton will be 10 centimeter, because 1 Newton is 1 centimeter, then 10 Newton will be 10 centimeter. This is our scale. And 6 Newton along y-axis. So 1 Newton is 1 centimeter, then 6 Newton will be 6 centimeter. 4 Newton along negative x-axis. So our 4 Newton equals to 4 centimeter. Next, but after choosing the scale, this is the same problem 4.1. After choosing the scale, with the help of the scale, I will draw these lines. So 1 Newton is equal to 1 centimeter, then 10 Newton is equal to 10 centimeter. Students, please wait for a second. I am coming back. So our numerical problem 4.1 continues. So I will take 10 centimeter is equal to 10 Newton is the 10 Newton force along x-axis, as I have discussed it. So 10 centimeter. So on x-axis, then our 6 centimeter is on y-axis. So I will take a scale scale and mark the line 6 centimeters along y-axis. Then I will take a scale again and 4 centimeters I will mark the line along negative axis. Okay. So 10 centimeters along x-axis because he has given us on 10 centimeter will be on x-axis, then 6 centimeter will be on y-axis, and then or 4 meter or 4 centimeter is on negative axis because this direction is showing negative axis. This direction is showing positive x-axis, and this direction is showing me uh, y-axis, positive y-axis, and this direction CD direction is showing negative x-axis. Okay. So what I will do, I will use the head to tail rule. This is the head to tail rule principle. The head of the first vector. When we add the vectors, the head where the head ends, the second vector will be on the top of the first vector. So the third vector will be the tail of the third vector is adding to the second vector, and its direction is on negative axis because he has given us this data. So if I want to find out the resultant of this force, how can I find this? By joining A to B. Take a vector and join this A to B, and the direction of this vector will towards the B. This will be our AD will be our resultant vector. So we were given three vectors AB, CD, and CD. Then how can we find the vector AD? By joining tail of the first vector to the end of the last vector. So where the two arrows meet here, that will be called the resultant. So if on layering with the help of scale, AD, if you measure the length of AD, it will come 8.95 centimeters. So it's not meter, it's 8.5 centimeter or 8.5 centimeter equal to 8.5 Newton. So 8.5 centimeter, 8.5 centimeter equal to 8.5 Newton. With the help of the protractor, you can also measure the angle by putting the protractor here. So at point A, you can find the angle of AD. This angle you can find by putting the protractor or D at point A, you will find this angle, and this angle would be 45 degrees. And the result will be 8.5 Newton. This is the required result. Next. Okay, problem number 4.2 now on page number 105. I read the numerical statement first. Find the perpendicular components of a force of 50 Newton making an angle of 30 degrees with x-axis. So students, on 4.2 numerical, what we are required to do, first of all, I know the given data. Force is 50 Newton. This is the force. You know the unit of force is Newton. So force is given to be 50 Newton, and the angle is given to be 30 degrees. So angle is denoted with letter theta, Greek letter theta, and angle is 30 degrees. In this numerical, what we are required to fx, which is x component of the force, and fy, which is the vertical component of the force. So we are required to find two things: the horizontal component of the force and the vertical component of the force. If you open the book page number, if you open the book page number 88, you will find this formula or under article 4.3 and equation 4.3 and 4.4, where fx is equal to f cos theta and fy is equal to f sin theta. These two formula to find x component of the force and the y components of the force are available on page number 88 of your 9th class textbook. So first of all, I find Fx horizontal component of the force, and the horizontal component of force is denoted and horizontal component of the force is denoted with the horizontal component of the force is denoted with the letter Fx, and the vertical component of the force is denoted with the letter Fy. So horizontal component of the force is denoted with the letter Fx, and the vertical component of the force is Fy. So our formula, this formula is available on page number 88 of your 9th class textbook. Fx is equal to F cos theta. So putting the values, the value of force is 50 Newton. So I am just putting the values 50. Force value is 50 and cos 30 and theta is 30 degree. If you take with the help of calculator, if you find the value cos 30, first of all take cos 30 with the value of cos 30 is 0.866 and then multiply with 50, you will get 43.3. This is the horizontal component of the force which are required. 43.3 Newton. Next, what we are asked to find. So our vertical component of the force, Fy, this formula, Fy is equal to F sine of theta is also on page number 88 of your 9th class textbook. Putting the value again. So theta value, theta is 30. So 50 times sine 30. First of all, you will take sine 30 with the help of calculator, and value of sine 30 is 0.5. If you multiply 0.5 with 50, you will get a vertical component of force which is 25 Newton. So this is the end of the problem. 4.2. At the end, you will write result here. I didn't write result here, but you got to mention the result over here. RESULT. Say when you do your numerical, write over here result. Fx is equal to 43.3 Newton and Fy is 25 Newton. So result will be horizontal component of force Fx is equal to 43.3, you must mention, and Fy is equal to 25 Newton. So this is our end of the numerical problem number 4.2, which was on page number 105. Now the next problem is 4.3, which is also on page number 105. Find the magnitude. I read the statement of the numerical. Find the magnitude and direction of a force. If its x component is, find the magnitude and direction of a force. If its x component is 12 Newton and y component is 5 Newton. So this is the statement of the numerical 4.3. In this numerical, he gave us the data. Horizontal component of force, x component means horizontal component of force, which is denoted with the letter Fx. X will be very small. It is only the subscript. Okay. So force Fx equals to 12 Newton. It is given to me x component. Whenever he says x component, then you will write Fx is equal to 12 Newton. And then y component of the force is also given to me, which is denoted with the letter Fy equals to 5 Newton. These are two forces, that's why its units are Newton. You know the unit of force is Newton. In this numerical, we are required to find magnitude of a force, and magnitude of the force is denoted with letter M, and this is a question mark. Direction of the force is also required, which is denoted with the angle gives us the direction. So theta is the question mark in this writing. These two things are required in this numerical. Magnitude of force, which is denoted with the letter F, and the direction of the force, which is denoted with the letter theta. Theta, this is the Greek letter. So I will use the formula in solution. I will use the formula F is equal to, this is under root, this is square root, this is all with, right? But the sign of the square root is some missing over here. But you got to remember that when you put the square root sign, this line will be extended or here. Okay. So this formula is also in your textbook. So if you, I will give you the page number. This formula is available on page number 80, 89 and equation 4.5. If you open ninth class textbook page number 89, and this equation is 4.5, you will find this formula. F equals to square root fx square plus fy square. Okay, I'm using this formula, so I'm just putting the values. You know, fx is the horizontal component of the force. I just put the values 12 and then take the square because the square is over here. So I just put 12 and then take the square. Then fy is 5. Then I take the square. So you know 12 square, if you, with the help of calculator, if you take the 12 square or you multiply 12 two times, you will get 144 over here, right? 140, 12 square is 144. Similarly, if you take 5 square, the 5 square will be 25. So if you add them up, 144 plus 25 is 169. If you take 169, square root of 169, with the help of your calculator, you will find plus minus 13. You know, plus minus 13. Why I am writing plus minus 13? Because whenever you open the square root, there are the two possibility comes. One possibility is plus 13 and other possibility is negative. But since force is a vector quantity and its magnitude force cannot be negative, that's why I am ignoring the negative sign and only 13 Newton positive 13 Newton will come. Again, the unit of force is Newton. Now, I have found the magnitude of the force. The first thing I have found magnitude of force F. F is equal to 30 Newton. Now, I find I will find theta, which will give me the direction or direction of force. This formula is also on page number 90. If we open 9th class book page number 90, you will find this formula, equation 4.6, theta is equal to tangent inverse Fy over Fx. You will get this formula on page number 90 of your 9th class textbook, equation number 4.6. So theta, the formula is theta is equal to tangent inverse Fy over Fx. Okay, I'm just putting the values. Theta is equal to tangent inverse 5 divided by 12 because horizontal component of force is given to me 5 Newton and the vertical component of the force is given to me 5 Newton and the horizontal component of the force is given to me 12 Newton. I'm just putting the values. Fy is equal to 5 and Fx is equal to 12. How will you take this one? How will you solve this? How will you solve this one? With the help of calculator, if you divide 5 divided by 12, whatever the value is done, use the calculator and take the tangent inverse. Tangent inverse. First of all, write 5 divided by 12. Whatever the answer is done, take the tangent inverse. Or you can write tangent inverse plus and then 5 divided by 12. You will get theta. Theta is the angle which is 22.6 degrees. 22.6 degrees. So our this x-axis. So the angle we found 22.6 degrees. Our result will be magnitude of the force which we just found F is 13 Newton and direction. Our theta will give us the direction and which is 22.6 with x-axis degree with x-axis. So our these are the two things which are required in this numerical. So this is the end of 4.3 today's lecture, because if I choose more, then you will have the difficulty to solve the question. So, in order to get it right or get it clearly, you need to practice these numericals at home again and again. 3 to 4 times, at least 3 to 4 times, you need to practice on the rough copy, and then you will be. Then once you done this, then transfer these three numericals side by side on the link register as we used to do. Okay, I repeat all the numericals now again for you for your convenience. So I'm going to repeat all the numerical again for you. So what we discussed today, today's lecture, we discussed about we discussed about only three problems, because in the last lecture we have done this 4.5 example and 4.6 example, and then MCQ we did in the last lecture. So today's lecture we did only three numericals: 4.1, 4.2, and 4.3. These three numericals are on page number 105. These three pages are not included in this lecture. So only 105, these three numericals are on 105. So first numerical we did this one. So I read the statement of the numerical first for you. Find the reaction of the following forces. It is given to me. If you open the page number 105 of 9th class textbook, you will see this numerical statement over there. So 10 Newton along x-axis, 6 Newton along y-axis, 4 Newton along negative x-axis. So to solve this numerical, we first of all we have to choose the scale. So I assume that 1 Newton force is equal to 1 centimeter. Then our 10 Newton force will be 10 centimeters. And similarly, our 6 Newton force will be 6 centimeters. And 4 Newton force is 4 centimeters. So our 10 Newton force is acting along x-axis, and our 6 Newton force, which is 6 centimeters, is acting along y-axis, and our 4 Newton force is acting along, which is 4 centimeters, acting on negative axis. Okay, so I draw on the paper uh, for you. So this is the continuation of problem 4.1. What I did, because 10 Newton force is acting along x-axis, so I took a scale and then marked 10 centimeters along x-axis. Similarly, you will take a scale and then draw a line 10 centimeters along x-axis. Why I'm saying x-axis, positive axis? Because the arrow will show this is on positive axis. Next, I will draw 6 centimeters along y-axis. So my arrow will show this is y-axis. This is towards y-axis, okay, which is 6 centimeters with the help of scale. You will draw the line of 6 centimeters along y-axis. Similarly, what will you do? You will take 4 centimeters scale of 4 centimeters and draw a line towards negative axis. This direction is positive x-axis. AB is towards positive x-axis. Then BC line is 6 centimeters, and this is along y-axis. And then CD is along negative axis. Okay. So what at the last, what will I do? I will draw the resultant with the help of the scale. I will join A point to D point and then measure with the help of scale. So this will be on measuring the scale will show 8.5 Newton force, which is equal to 8.5 centimeters. So similarly, you can find the angle by putting the protector over here at point A. You on measuring, you will find this will be 45 degrees. Okay, these two things are required. Once is resultant, which is by 8.5 centimeter, and our angle is 45. Next, problem 4.2. Find the perpendicular component of a force which is 50 50 Newton making an angle 30 degrees with x-axis. So in this numerical, force is 50 Newton given to me and angle is given to me 30 degrees. So what are required? Horizontal component of force and vertical component of force. I have already told you the page number of this formula, where these formulas are available on your text class, the next class textbook. Fx is equal to f cos theta. Just putting force is 50 Newton and theta is force is uh, yes, force is force is 50 Newton and theta is 30 degree. So if you solve this cos 30 take with the help of calculator, take cos 30, which is value 0.866, multiply with 50, you will get force horizontal component of force, which is 43 points. Similarly, with the help of this formula, Fy is equal to x minus theta, putting the values force is 50 and 30, sin 30 is 0.5. So if you multiply 0.5 with 50, you will get 25 Newton. So at the end, you will write the result. Horizontal component of force is 43.3 Newton and vertical component of force is 25 Newton. You got to write by yourself. Next, problem 4.3, which we discussed today, it is available on page number 05. I read the statement, find the magnitude and direction of the force. If its x component is 12 Newton and y component is 5 Newton. Again, in this numerical, we were given fx, which is horizontal component of force, which is 12 Newton. X component, when he says x component, it means horizontal component, which is given to be 12 Newton, and the y component, which is the vertical component, which is also given, which is given to be 5 Newton. In this numerical, what we are required, magnitude of the force and direction of the force. With the help of this formula, F is equal to Fx square plus Fy square. So just put the values. So Fx is 12, Fx is 12, then Fy is 5 square. So if you 12 scale is 144, 5 scale is 25, so it's gonna be 169 under root. If you take under root, you will get plus minus 30. So force is always positive, so I will ignore the negative sign. So force will be 30. So I also find the direction. So direction you can find with the help of direction you can find with the help of this formula. Theta is equal to Fy. Fy is tangent inverse Fy over Fx. Theta is equal to tangent inverse 5.12. So the value of theta will be 22.6 degrees. So our magnitude of force is 30 Newton and direction is 22.6 degrees. These two things are required. I hope you guys understand this numerical. Please practice as much as you can on your rough register before doing this on read register. And if you have any questions regarding these, please